Okay, thank you for hanging out here all day, waiting for me. Title of my paper is Ongoing Intelligent Decision Management Tools for Repair, Evaluation, Maintenance, and Rehabilitation of Bridge Infrastructure. The letters in red I'll explain here shortly. I want to acknowledge two people. Professor Jimmy Kim, he encouraged me to, I'm his colleague, he encouraged me to come here, so I appreciate that. And I want to also recognize my co-author Farnoosh. Professor Farnoosh is from the computer science department and encouraged me to get involved with cross-disciplinary, multidisciplinary research. Overview here, where did I learn infrastructure maintenance? Talk about just real quickly research with the city and county of Denver. I'm going to present two artificial intelligence neural network studies, one on bridge deterioration, that is a Colorado Department of Transportation project, which we called Advanced Neural Network. And the second project is on biometrics, where I instrumented construction workers with devices to measure their heart rate, core temperature, posture, acceleration, and so forth. Artificial intelligence, it's everywhere. I learned repair, evaluation, maintenance, and rehabilitation in 1987 to 1994. I worked for the Corps of Engineers under a program called Repair, Evaluation, Maintenance, and Rehabilitation. Those red letters were in my title, and I give respect to that particular group for teaching me. That was 1994 to present. I'm a professor of structural engineering. 2009 to present, chair of civil engineering, and 1997 to present ongoing research work with the city and county of Denver. Numerous hundreds of students have been involved in this particular research, where we're able to get all sorts of hands-on applied research, maintenance, rehabilitation. So this is my dumb attempt to try to look smart. My professor, my friend Tong here, is going to answer any questions on neural network stuff from Penn State. But nonetheless, we researched a lot of theory in both of these particular studies with the computer science department. And I think the neural networks are multiplying amongst themselves, okay? Learning, and new ones are being developed as you ongoing there. We use all sorts of statistical root mean square, I think is the common way to look at your models and how they behave. For the heart rate study, we used two of the STM models and a GRU model to predict heart rate for a particular construction activity. For the bridge condition index study, we use CNN and TCN, just common off-the-shelf methods to combine with weather and traffic to predict condition. So if you're into any sort of physical fitness activity, many of these Fitbit type stuff off the shelf. We used a model called Zephyr and attached it to the bridge rehabilitation of an expansion joint in Denver, Colorado. Below is what you would get out of just common physical fitness models of Garmin, like I'm wearing here. We use percentage of heart rate return to see what the humans while they were doing their activities. Go through these slides very quickly. Heart rate of 5 participants through a 10-hour day while they're doing construction activities. There's a photograph to the left, and then it zooms in at the particular activity, what their heart rate was. Okay, so here they are, break time. I'll just pop through these real quickly. Removing concrete joint, day 1, day 2, getting the cut and torch out. Break time, day 3, we're in day 2 yet. I'm just going through some of these real quickly here. They're cleaning out the joint on day 3. Break time. This guy took a nap, see that? Heart rate, nice resting, low resting heart rate. Putting the body armor in on the expansion joint. Placing the concrete, day 4. Break time. threading the gland for the expansion joint. So all in all, lots of activities we monitored on all the 4 days and tried to correlate back and forth with that particular activity. Heart rate zones are easily published. We just broke it into fifths for strong, sedentary all the way to high impact. You can see that the participants were anywhere between the first two and the levels 3 and 4, some high range activity. And when you look at it on a average basis, there's publications that will indicate that if it's above a 30% heart rate reserve, it's considered a high cardiovascular activity. Everybody was above that. And I think we know that construction activities, field activities, very high cardiovascular. The fun part of this was to predict heart rate based on activities. And this is where we're getting into the neural network stuff. This is one participant where his heart rate was compared to the best 3 performing models. And we were able to predict 5 to 10 minutes into the future what his heart rate would be, okay, for a particular activity. And you can think of all sorts of applications that one could do with that. And perhaps they are. We didn't find a lot of heart rate based activities in the literature that are due to construction. There's lots of stuff with sports and everything, but with construction, we didn't find that. Second study was bridge deterioration forecasting, predictive analysis. We call this an enhanced neural network funded by the Colorado Department of Transportation out of our big data mining out of the computer science department. We use CNN, TNN plus. We have over 7,000 bridges. Combine that with these 2 models and weather and average daily traffic to use that as our predictor. This is the very first paper I published in 1988. This is a flow chart of inspection, rating, maintenance, rehabilitation, life cycle costs, that sort of thing. This is the very first paper I published in 1988 when I was with the Corps of Engineers. So what are we, 30 years later? This is what that workflow looks like out of the paper with all the neural network stuff. I know very little about this. I'm an applied user of neural network, and I'm trying to learn more as I go on here. We call it IBM. You could say iconic, immaculate, interesting, irritable, ingenious, ideal, impactful, but it's intelligent bridge management is what we're calling it. This graph was in that same paper in 1988, just a very simple condition rating graph. In 2022, using it on structure inventory and appraisal form number 59, which is the substructure of one bridge in Colorado, we can predict the condition now with some smartness, hopefully, okay, of what's going on. I was just in 1988, a curve like this, input some maintenance, and I've heard lots of neat maintenance rehabilitation schemes all morning here, all day, and that would be the bump up. And anyway, that's number 59. So how are we going to use this with the city and county of Denver? We have about 641 bridges in the city and county of Denver. That graph represents the current state, different types of that rainbow color graph there. Current state way to the left. Next data point is 10 years, 20 years, 30 years. Just our feel for how the structures are going to be going into different areas. Really no analytics behind that. So my goal then is to apply this stuff that we've learned with Colorado DOT to make that rainbow graph smarter, okay, that has some basics to it. This is me last month in Kona. I'm an Ironman triathlete, so just a couple islands away, swim, bike, run. That was my last one. I did 30 of them. Finished all 30 of them, so I'm kind of undefeated when it comes that way. But again, big data and human performance. We're using that in lots of different ways here. If you look at the NFL, that's all they talk about. The analytics say this, the analytics say that. Should we go for it or not on 4th down? They're just using neural networks, right, Tom? Okay, that's all they're doing there. Okay, it's everywhere. That's it.